Yeah?
What do you wear? Just normal wear, like what I wear now.
So I am recording, so anything you're saying is going to be on the tape. So just saying. Right. So you remember we covered blood composition and we covered blood groups. Yeah. So the next part which I need to cover today is transport of carbon dioxide in blood, and then we're going to move on and start looking at the blood vessels. So you remember there is one question in the assignment which is asking you about transport of oxygen in the bloodstream, and that's the bit we already wrote about in class. We had a diagram and we based that explanation on the diagram. Does everybody recall that? So that diagram included picture of alveolus, and we talked about how oxygen gets hooked onto hemoglobin and then travels along and then diffuses into the blood cells. So all I'm saying is that bit we've done. But another part of the question was about transport of carbon dioxide, and that's the bit we're covering today. I'm going to write down that as a little title. So transport of carbon dioxide. Okay. And this is part of the question which people usually find quite tricky, because it involves a little bit of chemistry, and I know that, you probably either never did chemistry, or if you did, it was a long time ago, and I do appreciate that. So you need to sort of try to pay attention and try to wrap our heads together around this topic, and then we'll just see how it goes. So in terms of transport of carbon dioxide in the bloodstream, there are three main ways in which carbon dioxide is traveling through your bloodstream. And I'm going to list them in the order from kind of the one which is the most, I suppose, most likely. So most of the carbon dioxide is going to be traveling through that system, all the way to the kind of least amount which travels. Okay? So the first method is traveling in your bloodstream in the form called bicarbonate ions. I'm going to write it down, so don't freak out yet, okay? I'll be time for that a little bit later. So in the form, oh, let me just write. So it's CO2 travels in the form of, so the first item, it's in the form of bicarbonate ions. Okay, that's your first method. So majority of carbon dioxide is going to be traveling in that form. Then the second way, or the second method that carbon dioxide travels is by being connected to hemoglobin, right? So connected to hemoglobin. And then the third and the final method is being dissolved in plasma. So dissolved in plasma. So you could actually look up online the percentages, relative percentages of each way in which carbon dioxide is traveling. And I'm going to leave that to you. Is that okay? Right? So I'm not going to give you the percentage, but you find it out, right? So what percentages are going to go with each method? Okay. And then we're going to kind of discuss each method in a little bit more detail. The trickiest one to understand is that first one, because that's the one which involves a bit of chemistry. Okay. So let's talk about this first way, the first one. So carbon dioxide, the formula for carbon dioxide, everybody knows that one. What is it? I'll already kind of wrote it down. What's it
CO2.
called? CO2, right. So with CO2, can somebody tell me where it comes from? Where it originates from?
It's one carbon atom and two oxygen.
Yes, so where does it come from in your cells? What's the process which produces carbon dioxide?
It's from the mitochondria when it in the aerobic respiration.
Right, exactly. So it's byproduct, the waste product of aerobic respiration. That's where it comes from. So your cell generates that carbon dioxide as a waste product of producing energy. Now, as soon as those cells produce carbon dioxide, very quickly it's going to come into contact with another really abundant chemical in your body. Which one is that? Does anybody have a suggestion? What's the most common thing, chemical, which is found in your body? One of the most common ones, anyway. Give us a suggestion. Hmm? What is it?
A chemical.
Yeah, well, yes, like a
Water.
water, absolutely right. Yeah, I think you're just overthinking it a little bit. Absolutely right. So as soon as carbon dioxide gets produced, it's very quickly going to come in contact with water. And water, what's the formula for water?
H2O.
H2O, so we know that. Perfect. So you remember the plus in chemical formula simply means that you're taking something and you're mixing it with something else, right? So it's a mixture of. And then the arrow to show that it becomes something else. So what does it become? So carbon dioxide, when it comes into contact with water, a lot of it is going to turn into this chemical, and the formula for this chemical is H2CO3. Anybody ever came across that, or maybe knows from previous, I don't know, GCSE or whatever else you did? Anybody knows what this is called, by any chance? Just wondering. Yeah.
Is it a gas?
No, it isn't. Not in this form. No. No.
Is this the condensation thing?
Well, I'm looking specifically, you're thinking about in terms of name of the reaction, but I'm thinking in terms of actual name of the product, the name of this chemical. Okay, so if we don't know, we don't know, that's fine. So this is called carbonic acid, so I'm going to write it underneath. So let's just write kind of the words to go with each chemical then. So this was carbon dioxide, and this was water. So I'm showing that when carbon dioxide comes into contact with water, it's going to turn into this chemical called carbonic acid. Now, unfortunately, that's not the end of the story, because something else occurs to this carbonic acid. I could have written it here as a continuation of that reaction, but I'm going to run out of space. So if you don't mind, I'm going to rewrite that carbonic acid and show this second step as a separate reaction. Is that okay? Yeah, but you just keep in mind, you could have written it as just continuation of that process. So it's H2CO3, which is my carbonic acid. So carbonic acid is essentially unstable, and it's going to break up into a couple of products. And that's what I'm going to show. So the arrow shows that becomes something else. So what does it become? The first thing, the product of that carbonic acid breaking apart, is this. H with a plus. And I'd like you to tell me what you think this is called. And to know that, and to remember what it is, you have to go all the way back to right at the start of the year when we talked about levels of organization. Chris, I want you to keep quiet, because you usually is the one who comes up with the answers first, and I want everybody to have a think rather than rely on you. Is that alright? Yeah? So can everybody have a look at, or have a little chat with somebody you're sitting next to, and use your notes from all the way from October, and try to remember what this is. What would I call this? What is it called? So what can you tell me about what's written on the board right now? This H with a plus sign on the top. So what is that? So this is something we discussed as a part of the levels of organization lecture right at the beginning of the year. Yes, right, so Chloe is getting there.
Is there
So
positive?
I can hear a few correct noises.
Is there
coming
positive
my way.
hydrogen?
So this is
A positive hydrogen ion.
correct, right? Anybody else got there? Yes? So H is
Hydrogen.
hydrogen, so I don't have much, but it's not an atom, which is what Chloe just said, right? So it's not an atom because it's not neutral. So therefore it's an ion, and you're absolutely right, it's a positive ion. So I can write underneath hydrogen ion. And just to take it one step further, not that you need to talk about it in the assignment, but just to see if you can recall that. So if I take this hydrogen ion, so what happened to the atom of hydrogen to make it into this ion? Can somebody tell me that bit?
Lost or gained one.
Right, well, has it lost or has it gained one, and one of what exactly? What has it lost or gained? No, the whole thing was an atom to start with, so if I lose an atom, then the whole thing is gonna just go poof and disappear. So something was lost or gained from that
Lost
atom.
an electron.
Right, excellent. Who else was, yeah, well done. Absolutely right. So it lost electron. How many electrons? One or more than one? Just one, exactly, because I only have one plus here. So it lost one electron, because you remember, electron is negative, so when this bit of negativity flies off from neutral atom, what's left behind is a positive ion, which is what happened in this case. So it's not just hydrogen ion, which is going to be a result of carbonic acid breaking up, that's just one part of it. So I'm going to draw another plus. Do not get confused between this plus and this plus. This is a little plus on the top of hydrogen to show you that it's an ion. This big plus in the middle shows you that it's hydrogen ion mixed with something else. Can you see that? So don't think that I made a mistake and put two pluses for some reason next to each other. They mean something different. So I'd like you then, and you can do it in pencil if you like, can you write down for me what do you think is left? So if I chip off one hydrogen from that, what is left behind? Can I give you 30 seconds or so to have a think about it? It's not a trick question, it's really simple. So if I take off one hydrogen, what shall I be writing here? Okay, have a chat. What do you think?
Well,
So I've taken that, took one hydrogen off it. What is left then? What shall I be writing in this space here?
HCO.
Right, okay, so Laura is going for it. So what am I writing on?
HCO3.
Do we all agree? Yes? Does that make sense? Alright, so all I've done is I've taken one hydrogen off the carbonic acid, so all I've got left behind now is the second hydrogen plus CO3. That's still left behind. And then guess what? That electron which left hydrogen, it's now went and hooked itself on that little monster here. And so that is also became a negative ion. Right, so let's see who was paying attention this Thursday morning. What do you think this is called? What do you think I should be writing underneath that little monster? In words, right? Anybody was paying attention? No? What shall I be writing? Right, Laura got it. What is it?
Bicarbonate ion.
Right? We're paying attention just a little bit, right? Some of us. Right, absolutely right. So this is called bicarbonate ion. Alright, good. Right, so what we need to do, so these are equations, but for the assignment, I'd like you to write a little sentence underneath each equation to explain it in words, right? So instead of it being just equation, put it in words. How are we gonna do it? Let's try to remember how we did it for transport of oxygen when we were describing oxygen getting hooked onto, for example, hemoglobin. So, from that lecture, which word shall I be using from chemistry when something is combining with something else? What's the clever word to use here?
Associate.
Associates, absolutely right. And when something is breaking apart, which word can I use there? Disassociate. Do you remember those words? Okay, can I write them somewhere on the side? So associates. Check my spelling, by the way, if I'm going wrong somewhere. So in this case, where I have carbon dioxide combining with water, which out of these two words could I be using to describe what's happening?
Associate.
Associates. And where I've got carbonic acid breaking up, which word could I be using? Disassociate. Can you have a go at then describing this sentence, this equation in a sentence and that equation in a sentence? Could I ask you to have a go with that? Alright? Alright, okay. So let's have a couple of minutes writing that down. So describe to me what happens in these equations in one or two sentences. So equation one. Think about how you did it when we were describing, as I said, oxygen combining with hemoglobin. Same logic. By the way, please feel free to discuss with each other. It's not, you don't have to do it independently. Have a chat with each other. Yeah.
Right, this bit, would it be the hydrogen that disassociates with it?
Yeah, but hydrogen ion, right,
Iron,
yeah?
iron.
Okay.
Yeah, that's what I prefer.
You could phrase it like that, and then just say disassociates into, and there are a couple of ways you can phrase it. So it's not like your start is wrong, you just need to think about prepositions that you're going to be using. Okay, so I can see that quite a few of you finished writing. Do you have anybody who is brave enough to read out their version? How can we describe, for example, this equation? Anybody wants to have a go? And we can sort of see if we're the rest of us on the right lines. No takers. Anyone? Or this first one, for example, how can we phrase that? Suppose I have a go.
Carbon dioxide associates with water, which becomes carbonic acid.
Acid, right, yeah, that's one way of putting it, yeah. No problem with that at all. What about the second one? Can somebody else have a go? Go on. Because then we can check if you're on the right lines.
Hydrogen ion dissociates with carbonic acid to become bicarbonate ion.
Say it again, go on. Say it again.
Bicarbonate ion.
Yeah, no, from the start.
Hydrogen ion dissociates with carbonic acid.
Right, you see, the only thing I've got a bit of an issue with is just preposition. Because with, it means we're together, right, can you see? Right? So, right, because, and you're trying to get rid of it, right, move away from it. So it's just changing preposition, so just check that you've got the right preposition. Can you see what I mean?
Yeah.
So if we're with them together, right, that doesn't suggest that you're trying to get rid of it, which is disassociate means. So it rather disassociates from, right, that's the only thing which I would tweak, but the rest is perfectly fine, yeah, cool. So coming back to the, kind of the first idea of transport, so what these two equations show you is that carbon dioxide is not traveling predominantly in that form of CO2, but instead what is traveling in your plasma are these sort of ions, including bicarbonate ion. So that's what's going to be moving with the bloodstream through your body. And so these bicarbonate ions are going to be created at the point of cells producing CO2, and they're going to keep traveling through your bloodstream until when? When do you think, what is the destination for these bicarbonate ions? Where are we moving them to?
Alveoli.
Correct, absolutely right. So we're moving them to alveoli. Now, my next question is then, are we going to be breathing out bicarbonate ions? Yes or no?
No.
No, absolutely right. So we're not going to be breathing out bicarbonate ions. So what's going to be happening then, in this case, when you get to alveoli? Well, what is going to be happening, unless somebody's got an idea, go on, Laura, what's your idea?
Reverse reaction.
Exactly, so the whole thing is going to go in reverse. So those reactions have got ability to go in the opposite direction. So I need to add another arrow to show that the whole thing can go back to the start. And so therefore, let me do those arrows in a couple of colors so we can easily tell them apart. Let me just grab some colors. My bag. I have some. So let's say the direction with blue arrows, that's going to be happening in the body cells. And the opposite reaction, let's do it in the other color. It doesn't have to be, by the way, red and blue. You can just pick any color you like. It's just I happen to have these two markers handy. So the opposite direction is going to be taking place in alveoli. Capillaries. Or rather in the capillaries which surround alveoli, let me place it more correctly. So now, your job is to describe those reverse reactions. The same what you've done just now, describing reaction going from CO2 all the way to bicarbonate. Can you now phrase it in the opposite way to describe what's going to be happening? So here we're going to be combining bicarbonate ions back with hydrogen ions to produce carbonic acid, and that's going to be then breaking up into water, carbon dioxide, and that's the bit when you're going to be breathing out. You're going to take that and breathe it out. So that's going to go across from capillary to alveolus, and that's what's going to be breathed out. Can you do that?
No.
Yes. Do you think you would like to have a go? Yes, please. If you find it confusing, by the way, right, if you find this whole reverse reaction a little bit confusing, I could have rewritten the whole thing in the opposite direction. Just for those of you who think that's going to be useful, I'm going to rewrite it here. Is that okay? Yeah, just an opposite. All I'm doing is reversing it. Can you see what I've done? Just written the whole thing going in the direction of red arrows, right? And that's going to be my reverse reaction. So when it comes to the assignment, you can either write it like that, with two arrows pointing in two different directions, and then describe it first going in the blue direction, and then going in the red direction. Or you can rewrite the whole thing from start, okay? To show that it's going from bicarbonate ions all the way back to carbon dioxide. So that's the direction I would like you to describe now. What is happening here? What is being combined with what is associating with what, therefore producing that, etc., etc. So put that reaction for me again in words. Is anybody stuck? Has anybody got something to write? You're all right. Yeah. Right, I can see most of you finished writing. Are we okay with that, right? So same logic, just be careful what you're saying in terms of what's associating with what to become something else. It's just again putting right words in the right order, making sure your prepositions are right. So either associating with or disassociating from. Yeah?
There's just something like the top one.
Right. So do you want to talk me through it then? What do you mean by confirm? Do you want to read it out and then I can tell you if
So would
it
it be
sounds right?
It would be carbonic acid disassociates with water to become carbon dioxide.
Oh, you're describing just that step?
Yeah, is that
Okay,
right?
so go on, say it again.
Is it carbonic
Carbonic
acid
acid.
disassociates from water to become carbon dioxide?
Well, I'm not sure if this is correctly phrased. Let me think. So you're saying carbonic acid disassociates from? I would say, yeah, Laura, you had a suggestion.
Disassociate with both of them.
I would say disassociates to become. Maybe, right? So to become water and carbon dioxide.
Okay.
Right?
Disassociates from what though?
Well, the word disassociates already suggests that it's just breaking apart.
Okay.
Yeah? Or if you wanted to phrase it the way you were suggesting, you could still do it, but then you probably would need to say something like water disassociates from carbonic acid to become then to become carbon dioxide. So something like that could work as well. So just be careful how you phrase it. And then maybe check against secondary sources. So have a look at the website or a book just to check that your wording is close enough to what the secondary sources suggest. Is that alright? Is the idea clear enough? Yeah? So once again, just to sum up, so in your body cells, you produce carbon dioxide, that combined with water became carbonic acid. This is just an intermediate product which doesn't exist very long, that broken apart into hydrogen ions and bicarbonate ions. So these keep traveling through your bloodstream until you get to your capillaries in the lung, and then the whole thing is going to go into reverse, so that you end up with carbon dioxide again, which you then can breathe out. Okay, when you're in your normal kind of rhythm of expiration and inspiration, right? So that's that first method. Remember, that's where we are. And this is out of the three methods. That's the trickiest one to understand. Now, in terms of how you're going to type it into the assignment, I would normally kind of have projector because I'm recording. Can we kind of just discuss it, and then later on this afternoon I can show you in a Word document as well. So I think we discussed already how to type something like CO2, correct? Right. So we're using capitals for chemicals, capital O, capital C, capital O. Then you just type in your normal 2, and then you use this little button on the ruler in the Word document, which looks like that. X with a 2 at the bottom, and that's going to bring down that 2 to the bottom. The same here, so 2 here and 3 here. Again, I'm going to highlight, press the button, and it's going to do that. What about when it comes to something like that? How we're going to deal with typing bicarbonate ion into your assignment? Anybody's got a suggestion for that one? No, not sure. That's fine. So this is going to be capital, yeah? Capital, capital, capital. 3, the same as we did it here. And then you're going to type a minus, right, or just a dash if you like. And then highlight that, and instead of pressing that button, again on the ruler, it's going to be another button with X at the top, with 2 at the top of X. So you just highlight the minus, press the button, and it's going to bring it to the top. Okay, and that's going to show you the ion. Right? So if you're a little bit unsure, I'll show you in a Word document. Yeah. I'll show you maybe a little bit later, just because I can't switch between the whiteboard and they're right next to each other on the ruler in the Word document. Yeah. Okay, so that was method 1. So can I just write all this down? Yeah. Okay, so then the second method this is where carbon dioxide gets bonded to hemoglobin. So carbon dioxide bonded. So for that, there is only word equation. There isn't a chemical equation. So it's going to be carbon dioxide. Again, because it's connecting to hemoglobin, I need a plus. And then arrow to show that it becomes something else. And what it becomes, I've got it written on a little piece of paper because I sometimes get lost how to spell it all. So it's called carbamino hemoglobin. How about that? Let me write it down. There you go. So you can kind of break it up into three: carb, amino, hemoglobin, but all squished into one word. So it's kind of equivalent of oxyhemoglobin. You remember when we were talking about oxygen combining with hemoglobin becoming oxyhemoglobin? Well, in this case, it's carbon dioxide instead of oxygen, and then it becomes that chemical. Again, same thing as you did before. Can you have a go at describing this equation using the word associates? It's the same logic as before. Underneath, let's write it as a sentence as well. Can you see? Or do you want like
So
to
what's that say? Carbonic hemoglobin.
Carbamino hemoglobin. Is that alright? Okay, and as you remember, the third method, the final one, is just being dissolved in plasma as CO2. So that last method, essentially carbon dioxide just doesn't change into anything, it's just traveling as CO2, but in very small percentage. So this is the least kind of likely method of carbon dioxide traveling. So here you don't need to write any equations, you just write a sentence that it's traveling, being dissolved in plasma, and that's about it. Now, because it's quite a technical question, I don't necessarily expect in the assignment to write a lot more in the form of independent research, as long as you can put those equations in the right order and put a few sort of logical sentences together to describe. That's about the extent of what I'm expecting from you. Is that okay? Alright? Because I appreciate this is quite a complicated topic which you're not, a lot of you won't be sort of super comfortable researching on your own. There are some links on the LE2 websites which can give you more information. but sort of, I'm not expecting to be, to write, for you to write a lot, lots and lots and lots on that particular question. Right, any questions or something which is not entirely clear? Yes, all good? Right.